So I'm going to go over the same problem as we saw in the tutorial, and this time I'm going to use a computer to solve it. And so here we have a gas stream containing 20 mole percent hexane, and the remainder is nitrogen. And the stream's flowing into a condenser where we remove a certain amount of hexane, and then the gas stream comes out and it contains a different mass fraction of hexane, and we want to know what the mass flows are of each stream. And so if we draw our schematic, we have a condenser, we have the stream coming in, stream 1, we don't know its mass flow rate, we don't know the weight fractions, but we do know the mole fractions. So here I'm going to say H is hexane, N is nitrogen, so it's 0.2 hexane. I know that nitrogen is 1 minus 0.2, which is 0.8, because those are the only two things in the stream. And then this condenser, I have a second stream that comes out. It's a gas stream, and so again, I don't know the flow rate of this, but I know the weight fraction of hexane, as they've told me, is 5%, and the weight fraction of nitrogen is 95%, is the remainder. And then I have a third stream coming off. The mass of this stream I don't know, but I do know its volume flow rate is a liter per minute, and I know that it's pure hexane. So, as we looked at before, we know that we can, our solution strategy, we find M3 from V3 using our density of hexane that we can look up. And then our second step is we're going to solve material balances, or MB. And in this case, our material balances are our total balance, or overall balance, is M1 being equal to M2 plus M3, right? The mass going into my system is equal to the mass coming out. And then for hexane, it's in stream 1, and that amount of hexane in stream 1 is going to be equal to the amount coming out in stream 2 plus the amount coming out in stream 3. This W3 hexane is just 1, so I can take it away. And then for nitrogen, it's going to be the mass of nitrogen in that first stream being equal to the mass of nitrogen in the second stream. So these are my three material balances, right? And I can use two of them to solve. Now what I'm going to do instead of doing this by hand is I'm going to use a Excel sheet to enter this information and to use a solver. So here I'm going to have my streams 1, 2, and 3. I've been provided certain information, so I know I'll write M in grams per minute, let's say, the mass flows. And then the other thing that I've been given for some of the streams is the volume flows. The mass flows are what I want. And so here for stream 3, I know it's a liter a minute. Now, I want to know the weight fractions of hexane and nitrogen in each of these streams. And for some of these streams, I know there are mole fractions of hexane and nitrogen. And so for stream 1, I know the mole fraction of hexane is 0.2. And then this for nitrogen is going to be 1 minus that 0.2, or 0.8. And then the hexane coming out in stream 3, they've told me the mass fraction is 0.05, so I enter that in. And if I want to enter a formula here, what I do is I press equals. I can do 1, the minus sign, and then I can click on a cell, and it'll reference that cell. And so you'll notice if that cell changes, then the other number will change. So my first step here is turning this volumetric flow rate into a mass flow rate. And for that, I'm going to say what my constants are here. I need the density of hexane, and this is 655 grams per liter, which you can find doing a Google search. And then I also need the molecular weight of hexane and molecular weight of nitrogen eventually. And so the molecular weight of hexane is 86.18 grams per mole, and the molecular weight of nitrogen, 28.01 grams per mole. Now when you're working in Excel, one other trick you can take advantage of is if you see there's this little kind of square at the bottom of the box, you can click and drag and it'll copy over the formula or whatever's in that box. So in this case it's just text, and so it'll copy over text. I could do the same with this number and it would copy them all over there. But I'm going to clear these since I don't need them here. So now we want to get our mass from our volume, so we take our volume. So again, I press the equals sign, I click on D3. I could also just say equals and then type in D3 and it'll select that cell. I do a Shift 8, get that little asterisk, that's my multiplication sign, and then I multiply by density. Again, you can click on the cell or type in H2, and then I press enter and I get 655, and we'll say grams per minute. And if I look, I have liters per minute multiplied by grams per liter, so the liters cancel out and I get grams per minute. And so that makes sense. Now one other thing I need to do is a mole fraction conversion, right? I want to get these into mass fractions. And so for this, I'm going to take my species. One is hexane, one is nitrogen. If I take a certain basis, so here I'm just going to say I have 100 moles of this stream 1. And so in that 100 moles for hexane, I'm going to have 0.2, which is my mole fraction, multiplied by the number of moles. And then if I click and drag this down, what it does is it copies over the formulas and it moves the spaces downwards. So instead of B6, which it was before, it's now B7, and it moves I10 downwards as well. And I didn't want it to move I10 downwards, so I can push that back up and I'll get the right number. Another thing I could do is I could put these dollar signs around the I, and then now when I drag it down, it keeps that I value constant. So it'll move the B value. It's moved from B6 to B7, but it'll keep that other value constant. So now I want to convert those moles to mass, and so I multiply these number of moles by their molecular weight, and that'll give me grams. So here I was in moles, here I'll be in grams. And similarly now when I drag this one down, you'll notice it's gone down to H2 or H4, which is fine. It's what I want, the molecular weight of nitrogen. And I've also gone down to H12, which is perfect. And then now I want my weight fraction, which is just one of the weights divided by both of those weights. And here I have a problem. I should have a I11 plus I12. And then now another way I can copy over this formula is the formula editing bar up here. So I just copied that using Control C, and then I paste it in here, it'll be the same formula, but then I put I12 on top. And I know that this is making sense because if I take the sum of both of these, you could just add them together, or you can use this function sum. You'll get that it's equal to 1, right? And similarly, this one I had calculated by taking I12 divided by the total mass. I could also calculate it a different way, which is 1 minus what we had before, and you'll see it's the exact same value. Right, so here's my weights, and I can make these cells reference these ones over here. Another way that I can do this is I can copy this, and if I pasted it, what I'm going to get is something that refers to other cells, and I don't want that, but what I want instead is just the value. And so if I copy here, what I can do is I can paste just a value over here. And so you'll see it's the same value as the other one. So that's a little bit about using Excel. And now we've got our weight fractions that we need for our streams. And I'm realizing these weight fractions should actually be right over here in stream 2. And for stream 3, we should have had just hexane and no nitrogen. And so now what I want to use is 2 of these balance equations. So I'm going to pick this one right here and this one right here. Remember, this third one I can get by adding or subtracting the other 2 together, and that means it's not independent. But you can pick any of 2 of these to solve. And what I want to find are values for M1 and M2 to make this consistent. So I want values for M1 and M2 that are consistent with those equations, so when I put in those values, they satisfy both of those equations. And now I could do this algebraically, and if you look at the other analytical video, you can sub in one equation to the other and solve. Another method that we can use to do this is with a computer. And so what I'm going to do is enter a guess for that first stream. So I'll say 1,200. Now if I use the mass balance, I know the overall mass flow of stream 2 has to be that stream 1 minus stream 3. Right, that's going to satisfy that equation. And then I'm just going to insert a row in here. And I'm also going to have the mass flow of, we said, nitrogen. And so the mass flows of nitrogen, I said it's M1 times the weight fraction of nitrogen. And that has to be equal to M2 times the weight fraction of nitrogen. And so my guess here has satisfied that first equation, right? So if I put in M1 on this side, it's equal to this. What I'll do is I'll write, let's say, equation 1 here. And if I look at the left-hand side, it's going to be equal to this, and the right-hand side is going to be equal to M2 plus M3. So that's fine. And equation 2, it's got to be this. So the mass of nitrogen in being equal to the mass of nitrogen out. And then if I look at whether this equality is true, so E1 both those sides balance out. But then if I take this down, E2, it doesn't, that second equation. So if I go back to look at my equations here, this first equation is satisfied by this guess, but the second equation is not. And so one way I could solve this is to continue guessing numbers here, and I could try to continue minimizing, this one right here. But I can also get a computer to guess for me, and that's where I have this solver add-in. And if you want to include the solver add-in, you go to Options, and then Add-ins. From there, Manage Excel Add-ins, and Go, right at the bottom of the screen. And then you're just going to put a tick mark on the solver add-in and click OK. In Macs, I think it's in the Tools menu. And so here, when I click on Solver, what it's going to have is a thing that says Set Objective. And so my objective here is going to be this cell. I want this cell, D12, to go to 0. When it's at a value of 0, it means I've satisfied both my equations. And the cell that I'm going to change is this mass flow 1. So I click on that cell and notice it says B2 with these dollar signs, D12 with the dollar signs is what it's going to 0. And then when I click solve, it's essentially going to guess. I'll just click keep solver solution, click OK. You'll notice this number 8.36 times 10 to the minus 5, very close to being 0. What else you'll notice? For that first equation, we have equality. The second equation, it looks like we have equality, and we see those flows here of nitrogen being roughly equal. And so my solution here is 1617 grams per minute for mass flow 1, 962 grams per minute for mass flow 2, and then for stream 3, 655 grams per minute. And so that's how we can solve some of these material balances using a computer.